So let me briefly tell you what we're going to do. We're going to start P2, the second section. I know I haven't done all the problems from P1, and I'll go back and do some of the problems from P1. And I was thinking that I'll try to record the class for an hour and a half. If something happens, I'm still at home. I think, yes, last time, the problem we had, I had too many windows open. I'll try not to do that. So we'll keep our fingers crossed. If something happens, I will, again, I know I'm repeating myself. I'll always rejoin you guys, okay? Give me good 5 to 6 minutes, go get a cup of coffee. I don't think it'll happen. And if this happens too often or something, I'll be happy to record a 10, 15-minute session and put it in our class, do some extra problems. So we'll try to compensate for that. It shouldn't happen too often. It happened in the university as well in the past, but it doesn't happen too often. And that's one of the problems with online teaching. But hopefully it's convenient for some of you. That's why we have it. So having said that, having said what we're going to do today, we're going to start the second section, P2, do some of the problems from P1. Other than that, do we have any questions? General questions. I mean, in class, we are recording. I'm not going to be able to discuss anybody's grades, and we haven't done anything that's related to grades. But if you have any questions, where is that? Where is that? Where are we doing? What the exams will be like? Do you have any questions before we start our lesson?
I'm all good.
Okay, good. And thank you for sharing. And again, anybody, I know you guys are very polite. You muted yourself, which is completely understandable. Even if you're sitting in a quiet place, my voice goes back to you. It comes back. It can be a little distracting. So it's a good choice, but you can always unmute yourself and chime in. Could you explain that again? Could you repeat it? Again, everything, hopefully everything will be uploaded, so you'll have one version of it. So let's go ahead. And another little thing, technically I could go back and do stuff from P1 and then start P2, but I choose to do the hardest things in the morning, the first thing. So let's start with P2, which is not really that hard, but it's new stuff. We'll do P2, go back and do some of the problems from P1. That's the plan. And we'll do some of the problems from P2 as well. One more thing, I did upload the problems in MATLAB for P2. You should be able to do most of them by the end of the day. One person emailed me. Of course, I can't use the person's name, but if you're here, it's relevant for, actually it's relevant to the whole class. So somebody told me, well, I am having computer issues and I can't do MATLAB. Well, it's not going to hurt your grade right now, but you want to make sure you do the MATLAB problems before each exam. Okay, because that's where many of the problems will come from. That's why. Okay, so let's see if we can share. Here's our class. I'm not going to go over it. And the more windows I open, the more things can mess up. So, but if you have any questions about the class, I'll just briefly mention, since we are here, this link here that says class link will have our session link. This is where you come at 9:35. Okay. And this is recorded lectures. This is where I will upload our classes. Okay. And they fluctuate, they go up and down. I'll try to put this on top. Okay. Close to the top. And this one, it doesn't matter. You'll have to scroll down. Occasionally I'll pull it up. Okay. All right, guys. So let's open our notes and start defining a few terms. So my notes are straight from your text, okay? So I'm gonna take a little topic and write down my notes, handwrite some of my notes, so you will understand. Of course, if I say something you don't understand, it's not a problem. You can always ask me to repeat it, or can you explain it again? All those things are fine. So all right, guys. So this is called exponents. We're going to talk a little bit about exponents today. Again, if I give you some problems to try and you want to try it, you can always go to Mathicon Polypad, share your screen, and you can do some work. And so everybody can watch you, everybody can learn from you. I know everybody in class is not ready for it, but I know some of you are. Okay, so we are going to talk about, by the way, I can make it a little bigger, but I guess not a whole lot for some reason. What this is, don't worry about the product rule too much. When we write something like this, 2 to the power 3, it's read 2 to the power 3. 2 is called the base. And 3 is called the power or exponent. Power or exponent. Okay, generally I say 2 to the power 3. All right, what does that mean? Well, that simply means you write 2 3 times and multiply them. So 2 to the power 3. Let's see. Writing is a bit choppy, but we'll fix it. 2 to the power 3 is simply 2 times 2 times 2, which is 2 times 2 is 4, 4 times 2 is 8. Okay, of course, you can use your calculator anytime, not a problem, but some of these are so it's easier. By the time you're going to pull your calculator, you'll have your answer. But you also want to know what it is, and we're going to see it in terms of X. This is an algebra class, so that's what it means. 2 to the power 3 is 2 times 2 times 2. What's 2 to the power 4? 4. You are going to write, well, let's see what we can do here. This little strip, we'll get rid of it. Okay, so 2 to the power 4 is going to be this. I'm going to write it here. 2 to the power 4 is going to be 2 times 2 times 2 times 2. And that's going to, my apologies for squeezing all that in. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that's that. So let's pause here for a couple of minutes, see if anybody has any questions. In class, we make eye contacts, right? And see who has questions. We can't do that too well here. I can't see your faces. So again, if you have any questions, just ask. Let me erase this. So of course, we are going to use those numbers 2 to the power 3, 2 to the power 4 a little bit, but mostly we will see it in terms of A, B, C, X, Y, Z. All right. What is that supposed to mean? Well, not a whole lot. It's the same thing. So let's do this. Okay, so we're going to claim that 2 to the power 3 times 2 to the power 4 can be written as follows: 2 to the power 7. Why? Well, it makes perfect sense. This is 2 to the power 3. That means 2 times 2 times 2. And this is 2 to the power 4. That means 2 times 2 times 2 times 2. And if you look at them as if they're together, I'm going to write it here for you. 2 to the power 3 can be written as 2 times 2 times 2. Forget about this for now. And 2 to the power 4 can be written as 2 times 2 times 2 times 2. And don't forget this multiplication sign. Once you put it here, what do you have? You have a string of 2 written 7 times. Where's 7 coming from? It's simply 3 plus 4. So 2 to the power 3 times 2 to the power 4 is 2 to the power 7. That's all they're trying to say here, guys. Okay, they're saying b to the power m times b to the power n is b to the power m plus 1. Now, b is called the base. Now, you have to make sure that the bases are the same. This 2 and this 2 must be the same. For instance, I cannot say this. 2 to the power 3 times 3 to the power 4. I cannot say it's 2 to the power 7 or 3 to the power 7. This formula is true only if the bases are the same, and they happen to be the same in my example. So they're calling it product rule. We're just going to say you can add the powers if the bases are the same. Let's pause there a little bit, guys, before we jump to the next one. And I like to give numerical examples, that way people understand things better, but it's an algebra class. So a lot of the things, when we do the problems, we're going to be seeing B, M, X, Y. Just be aware of that. Moving on, guys. Yes or no? Okay, I'm going to move on, guys. If you want me to, if you want to ask something here, just unmute yourself and say, yeah, go over that again. Okay, so this is kind of repetitive actually, but I will go over it. Well, it's not real. Yeah, it's kind of the same thing. Okay, so this is called quotient rule. Fine. Okay, not a big deal. They're claiming, I'm going to give you an example. Just like before, if the powers are the same, if the powers are the same, if the bases are the same. So I'm going to give you an example. 2 to the power 5 divided by 2 to the power 3, 2 to the power 3. I know when you say it fast, it sounds like a different word. 2 to the power 5 divided by 2 to the power 3. According to this formula, I can subtract n from m. I can do that. So it should be 2 to the power 5 minus 2 or 2 to the power 3. And that also makes a lot of sense, guys. I'm going to explain it here. I'm going to see if my finger, let me see. Well, no, I'll try my mouse. That's okay. So guys, 2 to the power 5. So why is it true? How do we keep it straight? If we forget, can we kind of reconstruct it in our head, or can we explain why this makes sense? So take a look, guys. 2 to the power 5 can be written as 2 written 5 times and multiplied . And you want to understand these a little bit. And 2 to the power 3 is kind of the same thing, except for this time around, we write 2 3 times and multiply them all together. And remember, from high school, middle school, you can cancel this 2, 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 you can cancel this and this. So 3 of the 2's in the bottom, cancel 3 of the 2's on top, and you're left with 2 to the power 2. And it shouldn't surprise you that this 2, the exponent or the power, is really 5 minus 3. So this is called quotient rule. We're going to use it a lot. It's based on cancellation. And here is a nice formula right here. I'll pause here a little bit to see if people have any questions.
I think we're all good.
Good, very good. Okay, I'm just double checking. I think I'm recording. I mean, somebody would have told me. Yeah, it says recording in progress. Awesome, guys. So let's move on. I don't want to open too many windows. So once I click that polypad button, guys, I know you can see it. The old stuff is gone, but of course I can recreate it. It's not the end of the world. Okay, another thing that's a little hard to kind of accept. It's really not that hard, but it's some people struggle with this a little bit. Okay, I'm going to explain it to you this way, guys. Remember, guys, from the previous slide, we said A It was actually B, so let's just stick to B. So B, 2 to the power 0 is 1. 3 to the power 0 is 1. Whenever the power is 0, the answer is not 1, it's 1, it's not 0. 3 to the power 0 is 1. Now, if you really want to know why we say that, to me, it makes sense. Take a look. Take a look. Remember, guys, previous slide told us b to the power m divided by b to the power n is b to the power m minus n. So take a look at this. I can say 2 to the power, we are using 2 too often. So let's use a big number, 5 to the power 3, whatever it is, 503 times multiplied, which is 125, divided by 5 to the power 3. You're dividing the same number by itself. The answer better be 1. Okay, that's easy. Now take a look, apply this formula to the left-hand side right here. What do you get? 5 to the power 3 minus 3, which is nothing but 0. And you get 5 to the 0 is equal to 1. So that's one way to keep it straight. That's one way to convince yourself, yeah, that makes sense. 5 to the power 0 is 1. 6 to the power 0 is 1. We are calling this the quotient rule. Quotient. It's really based on the quotient rule, but it's something you have to kind of remember. Don't write 0 here. Don't write this. I'm gonna write it, and I'm gonna put a little cross on top of it. That would mean it's wrong. Don't do that. And people do it. Okay. Moving on. Any questions, guys? All right. So the next one, this one, it gets a little, I mean, I don't know what to say. It doesn't get tricky, but it gets a little more abstract. Now, this is something you can kind of show it, but it's something you have to you can remember. We will define negative exponents. So 2 to the power negative 3 can be written as 1 over 2 to the power 3. I can prove it to you why that makes sense, okay? If you really want, but it's something you can remember. It's not that difficult to show. Once again, 3 to the power negative 5 can be written as 1 over 3 to the power 5. That's all they're trying to say. All right, so that's how they're writing it here. Okay, you can use the same principle. If you have something like this, 5 to the power negative 3, and this 5 to the power negative 3 is in the denominator, you can always move it up and the power changes to positive. Once again, if you have a power, that's, remember, numerator, denominator, okay, 2/3, 2 is the numerator, 3 is the denominator. Whenever something goes from top to bottom or bottom to top, and if they have a power, the sign of the power changes, okay? It's called negative exponent rule. It's right here. It's something we're going to use a lot, and sometimes we're going to use it because it will help us simplify things, and things will look much cleaner. So that's one of the reasons we do it. We use it. Again, don't be shy. If you want me to repeat something, if you want to give another example, ask me to explain something, unmute yourself and do it. And if you're comfortable, you want to share your screen, you know how I'm writing with my mouse. I don't know how well you can see. I'm just writing with my mouse. My computer allows me to write with my finger, but I'm not so comfortable. So you can, if I can do it with my mouse, you can too. So moving on, guys, moving on. Actually, the next one kind of explains what I just did, so I'm not going to worry about it. Okay, a couple of other things, nothing fancy, nothing fancy. I'm going to take, I'm going to take this. Nothing fancy, which very intuitive. So, like you would expect, okay, they're calling products of powers. So if I write 2, I like to give number examples, okay? These formulas are right here, 2 to the power 3, and I have a power of, let's make it, actually, guys, let me see. I'm going to make this 5. 5 times 3 to the power 2. So this formula tells us this 2, the exponent belongs to the 5. I can write it like this. And this exponent 2 also belongs to 3, like you would have guessed. When you have something outside the parentheses, it applies to everything inside the parentheses, like we know. So 5 square is 25. And 3 square is 9, and whatever 9 times 25 is, I think I know this one. I think it's 225, not that it matters. Of course, you can use your calculator. Okay, so the power outside the parentheses kind of distributes. It applies to A, it applies to B. That's all they're trying to say. Products to powers. And even before I go to, I mean, I don't even have to bring the next slide, guys. You would guess the same thing holds if you have something that's written like this. That's the next slide. I'm not going to bring it because it's really very related to what we're doing. So this 2, the power applies to 5. And the same 2 also applies to 3. Hence, the answer is 25 over 9. I think I can improve my handwriting, but I'm not going to worry about it too much. So that's kind of our lecture, guys. Okay. I'm going to pause here a little bit to give us a little breathing time. And actually, guys, it's not a bad time. I think in a couple of minutes, this little Zoom will tell us the session is about to end. Why don't we pause here a little bit? I'm still here. When we come back, we'll quickly come back, of course. We're not being kicked out. The computer didn't shut down on me or anything. We'll come back and do some of the remaining problems from P1. And then we should have a little bit of time to do a few problems from P2. We just wrapped up the P2 lecture. But I'm going to be here. I'm going to see if you have any question. Can you explain that again? What did you say over there? Those questions.
So do you want us to leave real quick, or?
Well, I was thinking about giving you guys a couple of minutes. If you don't have any answers, of course, we'll leave once kind of I get a feel that nobody has any answers. Are we all okay then, guys? Okay. Go ahead.
So with the negative, I think it was with the negative number with an exponent where you change it to a fraction.
Good question. Good question. Okay. Very good question. So I'm gonna, yeah, it's something I can address in 2 seconds. So let me go back. So we didn't quite address it. I would address it when the time comes, but it's a valid question. So is that what you're asking? Negative?
Yeah, I was just wondering, what do you do if it's already in a fraction?
Are you talking about negative numbers or fractions?
Well, what if like the fraction is negative?
Okay, so something like this. Is that what you're saying? Okay, I didn't address it, but let's address it here on top. Okay, the negative rule, guys, when you multiply negative number twice, you get positive. When you do it 3 times, you get negative. So if this is even, like 4, 6, the answer will be same as, so if you have negative 2 to the power 4, the negative 2 times negative 2 4 times, it's even, so it's going to be same as 2 to the power 4. And if it's odd, it's going to be negative 2 to the power 3. Does that answer your question? If this exponent is odd, the negative number will stick out. And if this exponent is even, the negative number will kind of vanish, because negative 1 times negative 1 is positive 1. And negative 1 times negative 1 times negative 1 is negative 1. That's the argument. Does that answer your question?
Yes.
Good. Don't worry, I'll do some of those. Just remember one thing, negative times negative is positive. So when you have another extra odd negative, that's going to make everything negative again. So if your power is odd, stick the negative out. If your power is even, make it vanish. Anything else?
All right.
Go ahead.
Oh, no, I just said, all right.
Good. So let's come back. Let's go use the same link to come back. I'm going to get out of this session and I'll rejoin you in a minute. Thank you guys. See you soon.